Yes, so please, the first presentation now about fly ashes in Japan by Hirofumi Sakanakura. You can now.
Yes.
Yes. Welcome. So you
Hi.
can now share your screen and start.
Yes. Okay. Can you see my slide? Okay.
Yes. So we have it in full screen. I think we can hear you pretty well. So I will just switch off my microphone and camera, and you can start. Thank you.
Yep. Thank you so much. Thank you for introduction. Hello everyone in Europe and good evening in Japan. I'm Hirofumi Sakanakura of National Institute for Environmental Studies. And thank you very much for giving me your time and attention to my presentation today. And now I'd like to introduce treatment technologies of fly ash from waste to energy incineration in Japan. Yep. First, let's take a look at the municipal solid waste treatment stream in Japan. In Japan, about 43 million tons of MSW are generated annually. And in total, about 79% of MSW are thermally treated by incineration and melting. And during such thermal treatments, organic substances become gases and water evaporates and the mass weight is reduced to 10%. As a result, thermal treatment residues, ash and slag, including fly ash, is generated in about 4 million tons per year. And currently, 3% of 10%, and that is 30% of the residues are recycled. And the ratio of recycling is increasing little by little. However, 70%, including most part of fly ash, still goes to landfill. I consider one of the reasons would be due to characteristics of fly ash. So, try to consider the factors affecting characteristics of ashes through the generation process. As is well known, after incineration of MSW, two types of ash will be obtained, fly ash and bottom ash. And today, the focus is on fly ash. Why fly ash is generated is because during incineration, small particles will be floated along with flue gas, and the flue gas contains acidic gas and low boiling point heavy metals. After gas cooling through boiler and water injection, some excessive lime and activated carbon will be injected in order to neutralize the acidic gas and to absorb heavy metals, such as mercury. Then, the mixture of fly ash and the air pollution control residues will be filtered at bag filter. As a result, the characteristics of fly ash become high pH, high concentration of calcium and chlorine, and also high concentration of heavy metals. And now, the gathered fly ash is taken to landfill mostly, but part of them are recycled. So, in the next slide, I would like to introduce an overview of fly ash treatment technologies. The treatment technologies of fly ash can be distinguished into two types, thermal treatment and stabilization solidification treatment. The thermal treatment are melting, vitrification, and sintering and recycling as raw material of cement. After thermal treatment, most of the residues can be recycled as construction material. Furthermore, byproducts from melting, such as secondary fly ash and metals, can be recycled as raw material of smelting. However, as I mentioned, currently, most of fly ash are landfilled after stabilization and solidification treatment. The technologies are chemical stabilizations using organic or inorganic chemical agent, and the cement solidification. After that, fly ashes go to landfill. So in this slide, I'd like to briefly introduce landfill sites in Japan. The upper left is a very large disposal site built in the sea. Large cities facing the sea, such as Tokyo and Osaka, dispose of waste at such marine landfill sites. Such landfills function in the sea to block water and keeping the water level inside a little lower and preventing dirty water from leaking to the surroundings. The upper right and the lower left are the inland landfill, which are before waste are put in. At the bottom, rain collection pipe can be seen, and the double liner are installed to prevent the leachate from seeping underground. The lower right is the type with a roof to prevent rain from entering. And under the roof, sprinklers are working to stabilize waste. And the leachate is cleaned and reused as sprinkler water again. Now I'd like to explain the regulations on fly ash to be disposed of in landfill. Fly ash is designated as a specially controlled waste in 1991, and fly ash must be treated to meet the waste landfill criteria. The focusing items are heavy metals and inorganics such as lead, cadmium, hexavalent chromium, mercury, arsenic, and selenium. They are evaluated by leaching test, explained in the next slide. And also volatile organic carbons, pesticides, and dioxins must also be evaluated. The leaching test to be applied is like the following procedure. The test is called JLT-13. After sieving the waste sample, more than 50 grams are mixed with 10 times volume of pure water. After that, the bottle will be shaken 6 hours horizontally, and the liquid portion will be separated from solid portion. Concentration of heavy metals and other substances in the liquid will be determined by ICP, for example, and then judged if the waste is acceptable at landfill. This slide shows environmental standard for soil and criteria in Soil Contamination Countermeasure Act and landfill criteria. Although the names of test methods are different, the procedure is very similar among the 3 leaching tests. So we can compare to say landfill criteria is 30 times relaxed than soil environmental standard. However, untreated fly ash cannot satisfy the landfill criteria, especially for lead. So treatment technologies for landfill has been focused on reducing the leaching amount of lead and the high pH condition of fly ash. The chemical stabilization is the main treatment technology applied to fly ash before landfill. Heavy metals in fly ash will be immobilized by chemical agents such as organic chelator, GHO carbamate, and piperazine, as shown in the figure. And phosphoric acid, iron hydroxide, and so on is also applied. And in Japan, organic chelator are the mainstream for fly ash treatment for disposal because the landfill criteria can be achieved easily. However, I should mention there are doubts in long-term stability of the chemical compounds. Furthermore, long-term COD loads and ecotoxicological effects are also suspected. The second treatment technology for landfill is cement solidification. As is well known, the process is to mix fly ash with cement and water and aging for days. Note that the treated ash is not necessarily hard enough to have a certain strength. cement reaction is not an instant reaction, so the leaching of heavy metals decreases slowly. So it is better to think that heavy metals are stabilized by chemical action with cement. This figure shows actual situation of fly ash treatment over Japan based on the statistics by Ministry of the Environment. And as of 2017, as much as 980 thermal treatment plants, including incineration and gasification, are working in Japan. The number of facilities doing chemical stabilization, red line box, or a combination of chemical stabilization and cement solidification is overwhelming, nearly 80% of the total. However, several facilities are applying melting treatment. Also, there are 88 facilities without treatment. It is presumed that the treatment is outsourced, including cement raw materials and melting at private companies. So I'd like to explain the recycling technologies of melting and cement raw material in the following slides. In the melting technologies, ash are melted at high temperature and cooled down to obtain MSW slag. The main feed of melting treatment is bottom ash, but fly ash can also be accepted. Besides, there are direct melting of MSW, which is also called gasification melting. And characteristics of the slag from bottom ash, from fly ash, and from direct melting are basically similar. The obtained slag is recycled as construction material, such as concrete aggregate and road construction material. As explained in the next slide, standards for concrete aggregate and road construction was published in 2006. Currently, about 540,000 tons of slag are recycled from about 200 facilities over Japan. And during melting, heavy metals will be separated from molten slag to metal and secondary fly ash. And the metals are being recycled as smelting resources. Also, part of the secondary fly ash are recycled as metal resources, but the rest are still landfilled. This slide just introduced the Japanese industrial standards of MSW slag for concrete and road construction. Although most of the heavy metals are separated from slag to metal and fly ash, there is a criteria for environmental safety, leaching and content to gain trust from citizens. And the leaching test method is also established, and the method is a little bit different from JLT13, GIS K0058 mixing blade method. In this test, in case of granular material, it can be applied without size reduction. In case of monolithic materials, test specimens can be applied as it is. So it is possible to test in a state close to the form used, not the raw material. And in this slide, I will explain the recycling of ashes as raw material of cement. Since the components of the ashes are close to cement, they can be accepted as cement raw material. However, ashes contain elements that are disliked by cement, such as chlorine and chromium, so only about 1% of the total feed materials can be substituted by ashes. Furthermore, pre-treatment for bottom ash and fly ash is required. In case of bottom ash, removal of big sizes and metals and crushing is necessary. And in case of fly ash, washing out of chlorine is required. About 380,000 tons per year are recycled, in almost all cement factories over Japan. I would like to introduce one more recycling technology, raw material of metal smelting, especially for fly ashes generated from melting furnace. The secondary fly ash has a high concentration of metals such as zinc and lead, and there are several smelting companies in Japan that can accept metal-rich waste, including fly ashes. As a result, part of fly ash from incinerator is also accepted, but not the main target. In this case, municipalities pay the processing fee to the metal smelting companies. And metal smelting company needs to perform pre-treatments such as desalination before putting them into furnace. Finally, I would like to discuss if fly ash can or should be recycled. In Japan, recycling of fly ash is limited to thermal technologies such as melting, vitrification, and cement raw material. And the amount recycled would be limited compared to bottom ash due to high content of heavy metals and salts, resulting high cost. Other stream is difficult, basically because fly ash is designated as specially controlled waste due to high concentration and leaching of heavy metals. It means recycling in construction without removing heavy metals should be avoided. So currently, most fly ashes are landfilled after chemical treatment to apparently stop the elution of heavy metals using chelating agents mainly. However, onic eluted from the chelating agent has become another new problem in landfill, and long-term stability of the compounds generated is also worried. So I'm also looking for a clue to solve the fly ash problem, and I wish information exchange with you for future. Yes, so thank you. That's all my presentation. Thank you very much for listening.
Thank you. Thank you very much.
Thank you.
Hirofumi. So Mikael here. Yes, so we got one question for you from a participant asking if the ashes are washed to eliminate salt before landfilling. So
sorry, you mean do we need washing before landfilling?
Yes.
We don't need to wash salts before landfill. In the landfill, we have treatment facilities, and we can, so in case of, in case of directly connected to sewage treatment system, we do not need to remove salts. So we don't need to remove salts before landfilling. Okay.
Okay. So the chlorine concentration is not a specific issue here. I see. Then I just wanted to add one question. You mentioned now that you want still, you said still that you have to solve the fly ash challenge. So do you see a lot of things happening in Japan now? So is there a lot of research programs, a lot of discussion in society about the fact that what is happening now is not good enough? What is the general atmosphere?
Thank you. Honestly speaking, there's not so big problem in Japan because fly ash can be accepted at landfill, and the leaching test, fly ash can meet the criteria for landfills by creating treatment. So I would say atmosphere, in terms of atmosphere, there's no problem. But as a researcher, I'm being worried about the future problem, perhaps, such as
because you presented the numbers, so a lot of the fly ash are landfilled.
Yes.
Still now. So,
Yes.
and what about the length? I mean, it takes a lot of space, and Japan has not much space. So
Yeah.
how do you see that can go on for very long?
Yes. Yeah. Actually, the landfill space in Japan is limited. So I think the priority of recycling is on bottom ash. Bottom ash is relatively easy to recycle compared to fly ash. So my research topic is now focusing on recycling of bottom ash. And after that, I should be engaged in the fly ash recycling.
Okay, so still the bottom ash because of the much larger volumes. That's the
Yes.
first focus. And even if the situation is not perfect for fly ash, it comes second for now. Now I see. We have time for maybe one more question. There was a question about dioxins content. Is there any regulation included concerning the landfilling?
Yes, we have a dioxin criteria. The content is, sorry, I forgot the figure. But yes, exactly, we have.
Yeah, okay.
So,
No, I mean, you don't have to give us the value, but yes, it is part of the values regulated.
yes.
Yeah. Now I see a lot of more questions. We still have a couple of minutes, so I can try to ask a couple of them. Are there any incentives, financial incentives to go towards recycling of the fly ash or reuse instead of landfilling? It costs money, like you said. So are there any incentives?
How to say?
Support.
Incentive. I think there's a, I'm not sure I have a correct answer, but in my opinion, there is no incentive.
I see.
So if the municipality doesn't have a landfill, they are very, how to say, very much efforts pay to the recycling if they don't have landfill. But in case they have enough space for landfill, they keep landfilling disposal. Yes.
Okay. Still one more question. I hope I will formulate it right. The fly ash from different types of waste streams.
Yes.
So you have municipal solid waste, but some other more. Are they all classified as the same, as specially controlled, like you call it?
Yes, in terms of fly ash, in terms of municipal solid waste fly ash, they are regulated as a specially controlled waste. Yes, from classification.
Okay, and for other like biomass residues or other more specific waste fractions?
No, so biomass incineration ash and coal ash, they are not specially controlled waste. Only municipal solid waste incineration ash is specially controlled waste.
Oh, I see. Interesting. Thank you very much again, Mr. Sakanakura. It was really interesting to hear about Japan. And now we are shifting a bit more towards Europe, but I think it was very good to hear from your country because of the very special interest there and situation. So I think we can go to the wrap up.